Yes, sir.
Okay.
Yes, sir.
Okay, so here we will start the second unit, and in second unit we will start from the X-ray diffraction. So as you have read this basic crystallography, where you have read about the Miller indices, Miller planes, and some basic introductions of crystal systems, Bravia lattices, and how many crystal systems are there, and how many Bravia lattices are there, and why we have uh, a few Bravia lattices. Likewise, we have seven crystal systems, and each crystal system can have either face center, a body center, end center, or simple primitive structure. But few crystal systems have these all. Likewise, orthorhombic crystal system, if you will see, then it contains the primitive, the face center, the body center, as well as the end center unit cells. So this XRD or X-ray diffraction is basically helps you to find out the crystal structure. Likewise, as you know, the crystal system, your crystal system is whether it is cubic, it is tetragonal, and orthorhombic. So how you guys can find out the information about that crystal system? So that information we can deduce from a technique called X-ray diffraction. So X-ray here, as the name suggests, we are using the X-rays and diffraction. So we will also see what diffraction is. So for this technique, the X-rays will be the fundamental source of radiations, which will help you to analyze the crystal structure. So yes. So first of all, the this term XRD contains this X-rays and diffraction. So X-rays, it is the these are the electromagnetic radiations. If you will see the spectrum of radiations, so this is the electromagnetic spectrum. So here you can see we have these gamma rays, X-rays, ultraviolet rays, visible rays, infrared, microwave, as well as radio waves. So this visible rays, which or the colors which we can see, they lies in the range of 400 nanometers to 700 nanometers. So if you have to see the small things or the things which are very small in dimensions, so then you have to change your then you have to change the wavelength of light which you are using to see those tiny objects. So here in this technique, we are using the X-rays. So X-rays have the wavelength which is generally falls in the range of angstrom. So they have a wavelength of 1 angstrom, which generally means it is 10 raised to the power 10 meter. So angstrom means if anything raised to the power 10. So here in this technique, X-rays we can use. So why we are using X-rays? This is the very fundamental question. So this question can be answered by the fact that the if you take the atom, or if you measure the size of an atom, so the size of the atom is comparable to the wavelength of X-rays. And what is a wavelength? So wavelength is generally, if you will see, this is the, so I think you all know about this. So it's just a quick review. So here you can see, if you measure simultaneously the distance between two crusts, so these are the top peaks, then we'll call this as the wavelength. Or you can measure the distance between the two troughs. So here, this top part, this is known as crust, and the bottom one is known as trough. So here, this wavelength is generally lies in the range of angstrom, or 10 is to the power 10 meter. And this wavelength, the size of the atom, if you measure the size of the atom, suppose this is your atom, then it has its size, which is comparable to the wavelength of this X-rays. And due to this fact, you are we are able to analyze the internal crystal structure, and these X-rays, when they will strike the atom, there are some phenomena like diffraction plays role, and due to that diffraction, we will have some constructive and destructive interference, which we'll see what are these. So here, so the X-rays were firstly discovered in 1895 by German physicist Röntgen. So he was doing his experimentations in laboratory. He accidentally discovered that there are some rays which can look into our beneath our skin. So likewise, we are all aware about the X-rays that if there's any fraction in the bone, then we generally perform this X-ray analysis. So these X-rays have very high frequencies. If the you can see from the spectrum that here these waves are placed very close to each other. So when they are placed very close to each other, it means they have very high frequency. And what is frequency? Suppose this is the point. This is a wall here. So in 1 second, how many waves can pass through it? Means how many wavelengths can pass through it. And if that waves number of waves are higher, then it means that have higher frequency. And if these are less, that means the considered region of the spectrum will have a smaller wavelength, or sorry, that will have a smaller frequency. So here you can see these are the higher wavelength. Higher wavelength means less frequency, and higher frequency means less wavelength. So wavelength and frequency are inversely related to each other. So why we are studying this X-rays? We are studying this, or why we are studying the X-ray diffraction? We are studying it because we want to know about the structures of crystals. So whether it is cubic, tetragonal, orthorhombic, monoclinic, or whatever the crystal structure it has. So you have the idea of this HKL. So this HKL generally represents the Miller indices of a plane. That if you have a plane, suppose this is by unit cell.
Excuse me, sir.
Yes.
Sir, can you please accept the joining request of 19 roll number?
Okay. So I think 75 have joined. Okay. So these slides are visible now.
Yes, sir.
Okay. 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 So you have read about these planes and Miller indices of planes, and as well as directions. So there, this HKL represents the Miller indices of plane. So here, if I'm talking about this plane, suppose, and here this is my origin, then by considering the coordinate system, suppose it is x, it is y, it is z, you can easily find out the HKL plane. So if we know the HKL value of any plane, then we can draw easily that plane in a particular crystal system. So now, if we have this DHKL value, so what this DHKL represent? So if you have two planes or more than one plane, then if you have to find out the distance between those two planes, then we use this term DHKL, where HKL we can write in the subscript. So this generally represents the interplanar spacing between successive HKL planes. Suppose if you have 111 plane, or this 110 plane, or any planes you can take. If you have to represent the distance between these two planes, then we use this
ले ले चार्जर ले ले केबल कड़े बा केबल कड़े कड़े अंशु बोली की भी बस सीट ही पाली जो बा केबल ही ने मैं लेके गयो बा नचू उसको ऊपर पड़ी है शायद केबल मिली है मुझे मुझे बन के बहन एक बार चादर सी चढ़ रही है कौन ठंडा क्यों गया कौन है वह डॉक्टर नहीं बड़े है कि कोई पिरामल या हॉस्पिटल का या हूं मैं जानकार तेरी है कि बता कौन तेरी जानकार कौन है अपनी बाड़ी में कौन आ गई थी? अब बाड़ी की हो या नहीं बता पहले बाड़ी बताओ क्या बेचे अपना पुरानी घर तो भी क्यों कर रहा तो नहीं बड़े जो ही वो जमीन ली तो फिर क्या कर ली तो बम्बू गाड़ी में आए आजकल पैदल चले ही नहीं एक ऊपर ताड़ ले पे लिया उन्हें उर्सी करके तो उठ भी गई मम्मी फिर मेरे तो घंटे में खत्म हुआ फिर खेला हमारे बैठो यार ले सुझा मैं अपलोड भी कर दी हूँ सुझा बड़ा हो गए तेजी 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 कौन सो वो बनाऊं मैं पड़े जेड लाके दे जल्दी से वो भी दे नहीं फोन ये तो जो दिया है कि तो मेरे भी फोन तो बैठा रिपेयर दिए ये तो चाहे दिया पर फोन तो रिपेयर दिए और फिर कोई नया भी होंगे बस मन हो गया। क्या हो रहा है? हाँ? हम्म हम्म कौन सा चश्मा दे दिया तू? लैड से लैड। कचन तो देख के देती। अरे बैठ जाओ। Tu खेलेगा कभी? अराबी ने इन अरे tu खुद आदमी ने देख तो आते का नहीं तो मुझे चला एक सामने आदमी ने बस तो बस कोई नहीं कर गया मेरे पहले तो इंडियन ये नहीं बता चमचिया वाली घटना कीड़ी आएगी तो लेकिन रात में 9:30 बजे सोए, सुबह 8:30 उठ के देख ले कि जल्दी उठूं। हाँ तो बज सोए कल मार हो गया रब जी मेरी छाती 11 बजे वो चल जाए 5:30 9:30 आवे वो क्या बोला ए वो भाभी जी तो खुदा गोबर आओ 10 बजे तारो जाएंगे खत्म हो जाएगा वो आज है हाँ, 10 बजे हप्पू हप्पू आवे 10 बजे 10:30 बजे सो गो के ये आधी घंटा कोई आवे भाभी जी बस 11 बजे तो चल जाए सारा गप्पू गप्पू सब चल जाए